guys, so as I told you, I was going to be completing a second video to go into a little bit more depth onto how to simplify radicals that get a little bit more complicated. So let's jump right in, okay? So when we are simplifying our radicals, you want to tell yourself two important things. And the first thing you want to tell yourself is the index. You want to look at that radical and you want to immediately identify the index, okay? That's the first thing. The second thing you're going to tell yourself is that, okay, so whatever your index is, maybe it's a square root, so your index is 2. So now you need to tell yourself, I need to pull out numbers with 2 copies. So whatever you fill in for your index, you're looking for numbers with that many copies. And this will make a lot more sense when we go through and actually do this together. Maybe your index was 3, you were doing the cube root, so then you need to pull out numbers with 3 copies, okay? So let's go through and do some examples so you can actually see what I'm talking about when I talk about the index and pulling out copies. What do I actually mean when I say that? So let's do some examples right now, okay? So I'm going to hop on over to my blank white screen so we can do some of this together, all right? And hopefully you guys can get a good feel for what we're saying. Okay, so let's look at our first example. So let's say I asked you to simplify the square root of 50, okay? That's what we want to simplify. So remember, the first thing I said you want to tell yourself is the index. Now remember, the index is that little number that we usually find here, but since this is a square root, we have that invisible number 2, okay? So our radical here has an index of 2, okay? Our index equals 2. So that means we are looking for numbers with 2 copies. So whatever your index is, you want to look for numbers with that many copies. So we're looking for numbers with 2 copies. And what do I mean by that? Because I certainly don't see any 2s, right? I certainly don't see copies of 2 anywhere. So what exactly do I mean by that? Well, I'm going to show you. So when you're simplifying radicals, what you want to do is you want to factor whatever your radicand is. You want to take your radicand and you want to factor it, right? Prime factorization. That's been such a big important theme for us throughout this semester. So I'm going to draw a line down the middle. I'm going to keep all my important information on the left side. You know, it's going to sort of walk me through this problem. And I'm going to do my work on the right side. So let me move myself over here so I don't take up any space. So I'm going to take my radicand, which is 50. And I'm going to do I'm going to take the prime factorization of it, you guys. So any 2 factors of 50, I'm going to start with 5 and 10. And then I ask myself, is it prime? Well, yes, 5 is, so I'm going to circle it, but 10 is not. I can break that down even further to 5 times 2. Okay. 5 is prime, 2 is prime. I've hit my prime factorization of 50. So the square root of 50, you guys, well, that's equal to the square root of 5 times 5 times 2, right? I just took these 3 factors that I found, 5, 5, and 2, and I broke up my 50 into 5 times 5 times 2. I can do that. So now remember over here, we said, okay, our index is 2, so I'm looking for numbers that have 2 copies. Well, now, do you see any numbers that I have 2 copies of? Oh, yeah. I have a pair of 5s here. I have 2 copies of the number 5. Well, since our index is 2 here, right? Remember, exponents and radicals, they are inverse operations. They cancel each other out. So I can bring those 2 copies of 5 out, you guys, okay? When I bring them out, I just bring them out as a 5. And I still have this 2 here. There's nothing to do with this 2, okay? I don't have another 2 so I can't pull a pair out, okay? This index of 2 just means that I'm pulling out pairs of numbers, right? That's what I'm doing. I pulled out my 1 pair of 5s. One 5 on the outside is equal to 2 5s on the inside. I pulled out that pair of 5s, okay? So I have my 5 out here. But I don't have another 2 underneath here, so I can't pull out a pair of 2s. So that 2 is just stuck, okay? So that is my simplified answer, 5 square roots of 2. So really what you're doing is you're looking at the index, you guys, and you're saying that anytime I have that many factors underneath my radical, I'm pulling them out, okay? And 2 copies for this particular problem, since it was an index of 2, 2 copies on the inside equals 1 copy on the outside. Because remember, radicals and exponents, they cancel each other out. Okay? Anything that I don't have that many copies of has to stay underneath the radical. So that has to stay there. So this simplifies to 5 square roots of 2. All right, so let's do another example because it always feels funny after the first example. We don't ever quite get it after one, you guys. Math takes a lot of practice. I always say that, right? It takes so much practice. So you will never just get it after one example. So let's look at another one. Okay, so let's say I said that I wanted you to simplify the, oops, I always do that, you guys. I want you to simplify the cube root of 24. Okay, we're going to simplify this. So again, I'm going to tell myself, okay, the index, what's the index? Well, this time it's really obvious, right? It's 3. So the index equals 3. So now I'm looking for numbers where I have 3 copies. All right. My index is 3, so I'm looking for numbers that I have 3 copies of. So I'm going to draw my line down the middle. I always separate my work from my problem, you know, and I write myself these notes. See how I'm writing myself those notes? On the left side, you guys, do the same thing. Write index equals 3. Write numbers with 3 copies. Draw a line and then do your work, because you can use this left side as a reference point. When you start doing this problem, you're like, what am I trying to do? Oh yeah, I had an index of 3, so I'm looking for numbers with 3 copies. That's right. It's like a map. You know, it's so important to remember what you're doing. So, okay, I have my cube root of 24. Remember, I'm simplifying it. So I'm going to take the radicand and I'm going to write the prime factorization of it. So my radicand is 24. I'm going to break that down into its prime factorization. So any 2 factors of 24, let's say I pick 8 and 3. 8 is not prime, 3 is prime, so I'm going to circle it, but I have to keep going with 8. I can do 4 times 2. 2 is prime, 4 is not, so I have to keep going even further. 2 times 2, beautiful, those are both prime, I circle them. So I can now say that the cube root of 24 is equal to the cube root of 2 times 2 times 2 times 3, okay? So 2 times 2 times 2 times 3. That's the same exact thing as 24. 2 times 2 times 2 times 3, that's equal to 24. So it's okay to break this down into its prime factorization. And it really helps us, as a matter of fact, because remember what we're trying to do. We have an index of 3, which means we're looking to pull out numbers that I have 3 copies of. Oh my goodness, look at this. I have 3 copies of 2. All right? 3 copies of 2. 2 times 2 times 2. So remember, that will pull out as 1, 2 on the outside. Or as 1, 2 on the outside. Okay? This index is telling you how many copies you're looking for. And when you pull that many copies out, it translates to just 1 copy on the outside. So when I pull that 2 out, when I pull those 3 2s out, it's just 1 copy on the outside. Okay? Now I need to see if there's anything left that I can pull out. Well, I don't have 3 3s, so I can't pull those out. So that has to stay underneath the radical. All right? So the cube root of 24 is equal to 2 cube roots of 3. And I cannot forget to put my index in there, okay? If I had forgotten to put my index, if I had just left it like this, that's 2 square roots of 3, which is very different, okay? I'm not looking at a square root, you guys. I'm looking at a cube root. So it's really important to remember to put that index in your radical, okay? Math is very specific. 2 square roots of 3 is very different than 2 cube roots of 3. And our index is 3 here, which means we're looking at cube roots, okay? All right, let's do another one. Let's do another one. We're going to keep going with this. Keep practicing, okay? All right, so now let's look at the square root of 180. Did it again. There we go. All right, So again, you guys, I am going to say to myself, okay, number one, whoops, what's my index here? Okay, it's the first thing you tell yourself is the index. So my index here is 2 because I have that invisible 2 there. Whenever there's not explicitly a number here, you can assume it's 2. This is a square root. So my index is 2, which means when I do my prime factorization, I'm looking for numbers where I have 2 copies. Okay? So numbers with 2 copies. Those are going to pull out. Those I'm going to pull out of my radical. All right? So let's draw our line. Whoops. Let's draw a line down the middle. I'm going to keep my notes on my left side, and I'm going to do all my work on the right side. So I'm starting with the square root of 180. So I'm going to take my radicand, which is 180 here, and I'm breaking it into its prime factorization, okay? So I'm going to start with 90 times 2. 2 I know is prime, 90 I know is not, so I need to keep going. I know that 90 is 45 times 2. Okay, again, 2 I know is prime, but 45 certainly isn't. 45 is equal to 5 times 9. 5 I know is prime, but 9 is not. 9 is equal to 3 times 3. Aha, I now have reached the end where everything is prime, okay? So it's fair to say that the square root of 180 is equal to the square root of 2 times 2 times 3 times 3 times 5. And I shouldn't have circled this 45. That was silly of me because I don't want you to think that that's part of the prime factorization. So I'm just going to erase that so I don't confuse anybody. I don't know why I circled it. When you do these prime factorizations, you guys only circle the prime numbers, all right? All right, so now I'm just going to rewrite my radicand using its factorization. So 2 times 2. And I'm going to write it as 2 times 2 times 3 times 3 times 5. And you'll see why I did that in a minute. You might already know why. I'm putting my pairs together, okay? 180 is equal to 2 times 2 times 3 times 3 times 5. So I can rewrite it like that. That's fine. So now I'm like, oh yeah, what am I trying to do again? Oh, I'm looking for numbers with 2 copies that I can pull out. So let's see what we can find. Well, I have 2 copies of 2 and 2 copies of 3. And that's why I paired them together, okay? So that those 2 copies of 2 will now pull out as 1, 2 on the outside. And those 2 copies of 3 will now pull out as 1, 3 on the outside, okay? So now I've got 3 times 2 on the outside. So I have 3 times 2. And then this 5, I can't pull it out because I need a pair of 5s. I need numbers with 2 copies. I only have 1 copy of 5. So that one has to stay by itself underneath the radicand, okay? Now I can't leave this as 3 times 2 because that wouldn't be simplified. 3 times 2 is what? It's 6. So this simplifies to 6 square roots of 5. All right, I don't need to remember to write my index here because it's a square root and that's my invisible 2. You can if you want to just get into the habit of always making sure you write your index in. Sure, you know, just to get into the habit of writing the index in, you can write the 2 in, that's fine. But you don't have to for square roots. If the index were 3 or 4 or 5 or 6 or anything other than 2, yes, you would have to write it in your final answer, okay? So that simplifies to 6 square roots of 5. So let's do even one more. Let's do even another one. Because again, math, the best way to learn math, you guys, is to do example after example after example. Practice, practice, practice until it becomes so automatic that you like want to throw up. All right, so let's look at our next example. All right, so now I'm going to say let's simplify the 4th root of 96, okay? So again, the first 2 things I'm going to tell myself. The index here is equal to 4, which means when I do my prime factorization, I'm looking for numbers with 4 copies, okay? How did I know my index was 4, you guys? Because my index is always located right here. All right, that's where you look. So now, sorry guys, same exact thing, okay? I'm going to take, when I'm simplifying my radical here, the 4th root of 96. What's my radicand? My radicand is 96, so I take my 96 and I break it down into its prime factorization. All right, I need 2 factors of 96. I'm going to do 48 and 2. 2 I know is prime, so I'll circle it. 48 is not, so I need 2 new factors of 48. How about 24 and 2? Let's do that. 2 I know is prime, 24 is not, so I need to keep going. How about 8 and 3? 3 I know is prime, but 8 is not. So how about 4 and 2? 2 I know is prime, 4 is not. I can do 2 times 2, and now I've finally gotten to the bottom of my prime factorization. Both these numbers are prime. I can stop. So now I know that 96 is equal to 2 times 2 times 2 times 3 times 2 times 2. All right, so I'm going to rewrite my radical, and instead of putting 96 as my radicand, I'm going to put 2 times 2. So I've done this one, I've done this one. I want to put all my 2's together. So I've another 2, okay, another 2, okay, another 2, and let me just check. I had 1, 2, 3, 4, 5 2's, 1, 2, 3, 4, 5. Great. And now I can't forget this lowly little 3. All right. So what was I trying to do? Oh yeah, I was simplifying this, which means that I had an index of 4, so I wanted numbers that had 4 copies. Okay, well, I definitely have 4 copies of 2, so let me count them off. 1, 2, 3, 4. Okay, so remember those 4 copies on the inside just translate simply to 1 copy on the outside. So I bring my 2 out. Okay, so 2. What's left underneath? A lonely 2 and a 3. 2 times 3 is 6. And I cannot forget my index, which goes right here. Okay, because this is not a square root. This is a 4th root. Okay, so this leaves me with 2 times the 4th root of 6. Okay, and that's the answer simplified. All right, we'll do one more, because like I said, the more you practice, the better you get. My children actually sing this song. They sing, the more you practice, the better you get, because we say it all the time here. Okay, so now let's look at one more, all right? How about we look at, let's look at a big one. How about we do, let's simplify the cube root of 250. Let's do that. All right, so remember the first thing I always say to myself is, what's the index? Oh yeah, the index is 3. Excuse my kind of hard to write. I have difficulties writing on paint, so I'm sorry if it looks sloppy. Okay, so my index is 3, which means I'm looking for numbers with 3 copies. All right. After I take my prime factorization, I want to take any number out that I have 3 copies of. Okay, so I'm going to draw my line down the middle, and let's get started with this problem. So now I can do all my work on the right side. So I'm looking at the cube root of 250. What's the first thing I do, you guys? I take my radicand and I break it up into its prime factorization. So let's start with that. I'll start with 125 times 2. 2 is prime, 125 is not. That's 5 times 25, excuse me. All right, 5 is prime, 25 is not, but 25 is 5 times 5, and both of those are prime. So I've now gotten to the bottom of my prime factorization tree, which means that 250 equals 5 times 5 times 5 times 2. Prime numbers are so important. Prime factorizations are so powerful, you guys. Okay, so now I can rewrite 250. Instead of writing the cube root of 250, now I'm going to rewrite it using the prime factorization instead. So I'm going to group all my 5's together. I always group numbers that are the same together. I have 3 5's, and then of course I have this lonely 2. And then I say to myself, what am I trying to do again? Oh yeah, I'm simplifying. My index was 3, so I'm looking for numbers with 3 copies. I have 3 5's here. Remember, 3 copies on the inside translates to just 1 copy on the outside. So this leaves me with 5 on the outside. And then I have my lonely 2. I don't have 2 more 2's. I can't pull it out, so it's got to stay underneath my radical. And I cannot forget my index. Okay, so my final answer is 5 times the cube root of 2. All right, or 5 cube roots of 2, however you want to say it. Right, so that is simplifying radicals, just a little bit more in depth. Okay, so if you have any questions, please feel free to reach out and let me know. And I hope you guys are all healthy and well, and I will see you soon. Bye.